Okay, so this video talks about how we're going to use combinations and permutations to find probabilities on such kind of questions. Here are two tips for you. The first one is whenever we use nCr or nPr, okay, these things picked, okay, must be without replacement, okay. That means once you've picked the first student, that student cannot be put back in this case, okay, because for nCr, nPr, no student is picked more than once, okay, otherwise it doesn't make sense. The other tips is when we are randomly choosing 3 or more things, okay, first of all, the tree diagram is always useful, and in this case you can consider nCr or nPr, okay. If you are choosing 2, maybe not. So back to this example, okay, we're choosing 3 students at random from 4 boys and 3 girls. What's the probability that 2 of these are boys? Okay, so we have set up the tree diagram, and these are the 3 paths that are desired. 1, 2, 3. Okay, so these are the paths for 2 boys and 1 girl, and here are the probabilities. Okay, but if you look at the denominator, they're all the same, and actually the numerators are also the same. Okay, it's just a matter of order. Okay, I first pick a boy and then a girl, or if you flip it around, okay, the numerator will still be the same. Okay, so how do we use nPr and nCr? Okay, of course in this case we are not doing nPr because there's no order specified. Okay, all we wanted is just 2 boys, okay, but at the same time that also means I want 1 girl. These 2 are the same because the 1 girl is implied. If we go back to the basics, okay, denominator would be the total outcomes, okay. In this case, what are all the combinations? In fact, we have a total of 7 students and we're picking 3 of them. We don't care about the order, okay, that's why we're using C. Okay, so what about the numerator? It would just be 2 boys from the total of 4 boys, so that would be 4 choose 2, okay, but at the same time I also want 1 girl out of the 3, okay, and we could multiply them together because we want boys and also we want girls, okay. Note that this part has already taken care of the different paths here, okay. We don't care about the different paths anymore, okay, because this has included, okay, and this will still give us the same exact answers. Okay, now let's have a very quick look on this quick question here. Okay, so we have 9 cameras named A, B, C, D, E, F, G, H, and I respectively. If we're going to arrange them in a row, okay, find the probability that D, E, F, and G are placed next to each other. So these 4 are sitting next to each other. So let's deal with the bottom part first, which is easy, okay, the total number of all outcomes. Okay, so we have 9 sitting next to each other, and now because we are arranging the seats, okay, in a sense, okay, the order does matter, so we are doing P, okay, so this would be just 9p9 or 9 factorials. So for the numerator part, there are 2 processes, right? The first step would just, we are going to combine all these 4 and treat it as one single unit, okay. So that means we have 1, 2, 3, 4, 5, and 6 units put together, and that would be 6p6. Now the second part is you focus on these 4 cameras and you arrange a seat for each of them, and obviously that would be 4p4 or 4 factorials. I'm not going to repeat all these in details because you should have done this in the previous chapter already, okay. And so the numerator would just be this, and so the answer would be 1/21.